Alright, so today what I want to work on is a project I started a little while ago but put down for quite some time. And it's a programming language that'll look something like this. I haven't fully decided exactly all the ins and outs of how it's going to work, but I think I'm vaguely settling on this. And the main gimmick, which is not visible here yet because I haven't added it in yet, but I will soon. Well, soon. It's somewhere on this list. The main gimmick is that I want it to be a quantitatively typed language, which means it both is dependently typed but also tracks usages. The quantitative typing is something that maybe I'll get to eventually, maybe I won't. I more started this project because I quite like dependently typed languages, but the languages themselves I don't like. In particular, I quite like the feel of Agda, but Agda is a very moving target, and in particular it's a vehicle for research. So it's not something that wants to be stable. It's not something that wants to be done. And they're constantly evolving everything into a different direction, as is the nature of research. They also evolve it in ways that I don't particularly care for. And another thing that I want to be able to have a language with good C integration. This is on the list down here. Ultimately, this compiling step, we're doing type checking today, not compiling. Ultimately, this compiling step will compile down to, I hope, idiomatic C. I've already given some thought to how this can be translated to C, and I think it'll work out. So what you expect to do, or what I expect to do, is to write all my like logic code, I guess, in the dependently typed language, and then have the things like I/O in C. So you have your main program be in C, and it calls out into the dependently typed language. We'll see how it ends up going. But for now, what we're working on is we're working on type checking. I have some basics for type checking working in here. Oh, do we not have... Do we not have... yes, I know why. I know why we don't have syntax highlighting. What's the easiest way to do this? Probably... Oh, yes, and I might as well get this going. Yes, so we want to go for... Where would it be? It'd be under Geeks, probably, maybe Geeks Home? I don't think so. You know what, we can probably search back for CAC. Yeah. This. And so what we want to go is we want to go 4F in, I don't know if this will work in fish shell. For now, yeah, we'll do all of them. Does it do? No. What we want to do is lnsf. Well, lnf is probably lnsf. Yeah, that's probably enough. Done. No. No. Okay. Then we'll take the lazy way out. I'll just copy Haskell here. There we go. Got some syntax highlighting. Okay, so we've already got some basic type checking. Not much. Most of it is just as unimplemented. which is the best kind of type checking. Ooh, we're seeing the ligatures in whatever font this is come out. Alright, so what do we want to type check? You know what, first we want to try to compile this, and I think it doesn't right now. Because I wrote this in micro Haskell. So it doesn't compile with GHC at the moment, so we need named field puns. Can we go cabal, turn on compiler flag? GHC options, okay, that sounds good. We don't need this. GHC options. How do I turn on named field puns? It's probably not this, it's probably like an X or something. GHC turn on language extension. We'll probably need a couple of them because microcabal automatically, yeah, it's X. Micro Haskell already has a bunch of extensions just built in, quite a lot of them actually. Okay, preference passing error cannot mix infix 9 with infix 9. Dumb, but okay. And where is this? This is in HashMap. One of the challenges in doing this will be to make sure I don't accidentally use something that's GHC specific. Or did I run out of space here? Oops. Buckets, cap, len. And this can just be cap. This can just be buckets. This can just be len, and this can just be cap. Cannot mix to infix. Or is this 55? Oh, it's misunderstanding the... That'll probably be a problem very soon. Couldn't match expected type hashmap KV with actual type V to hashmap KV. The equations put assume cap have 4 value arguments. But its type is 3. Oh. Could not deduce integral hashmap KV. From the context hash bouquet. $59. Oh yeah, because it doesn't know about the dots. Okay, we need to fix that because we make use of that a lot. microhs. Probably like record punning is probably one of them. Overloaded record dot, overload record update. Let's start with overloaded record dot. I wonder if that will solve that problem. It did. Okay. And then we'll go Clang toolchain. Okay. Instead of GHC options, use extensions. Okay. Named field puns. I presume this is a list of them as well. It just wants me to put a space there. Instead of GHC options, use extensions. The field extensions is removed. That's a good experience. The package list for... Oh, I thought that said 77 years old. That's impressive. Okay, what else are you bitching about? Packages using cabal version greater than or equal to 1.10 and before 3.4 must specify the default language. Can I just use 3.4? I'm kind of surprised how little we had to do to get the Haskell compiling. Like just overloaded record dot and named field puns was enough. Nope, not quite. Whoops, accidentally have some tabs. These modules are needed for compilation but are not listed in your .compile file's other modules. Okay, fair enough. I don't feel like I should have to. In fact, I am going to ignore them. I will even do GHC options, W missing home modules. I wonder if I can do W no? I can, okay. Now it's complaining about end. That's probably overloaded record update, probably. Damn it, Vax3, how do I use your fucking thing? Okay, rebindable syntax is required if overloaded record update. Okay, do we have rebindable syntax? Doesn't look like it. Duplicate record fields, I want that. And you're claiming rebindable syntax is required. Okay. Is there some prelude extension that's stopping me from doing this? Not in scope from integer? Jesus Christ, okay. Flexible. Binary literals? No, I'm not using binary literals. At least not yet. Lambda case, I know I'm using that. What else have we got here? Qualified do? I don't think so. Do I need to say that I need prelude? Surely not. After searching the rest of the dependency tree exhaustively, these were the goals I most had trouble fulfilling. Surely I don't need to import the prelude. That seems wrong. Do I need to give the language extension? The language subset I'm using? Language version? Oh, is it not complaining now? Language version Haskell 2010. Default language in field for each component. The component uses different languages in different modules. Okay. So this should be default language. And I guess that has to be here. Requires Haskell 2010. Well, that didn't do anything. It feels like I'm missing the prelude. How am I missing the prelude though? Unknown extension overloaded record update. Alright, well, get rid of it, I guess. Oh, yeah, I was complaining about tabs somewhere. Can we just quickly fix that so I don't forget? No, apparently. Do I really need to import Word? Import data Word, probably. Is that really required? Edit hash map. Import data Word. It is apparently. So if we edit source, we need to do the same thing here. Not in scope get field. Not in scope get field. What do you want about? Unexpected, okay. There's definitely something here. Oh yeah, can we do back to 3.4 here? Not in scope if then else. Like it really just looks like I'm missing the prelude. How do I get the prelude? Haskell Cabal missing, maybe missing prelude. Module import base prelude. A workaround would be the language extension no implicit prelude and package imports. No, but I want it to import the prelude. Build depends. Yeah, we got base. It doesn't have a version though, is that the problem? Greater than or equal to 4.6? No. Default language, Haskell 2010. Yeah, and it doesn't like that apparently. Oh, well that's not how you spell Haskell. Okay, that didn't help. Other modules. Source. No, that didn't help either. You've omitted the base dependency. I certainly have not. Not in scope. Build depends. It certainly has base. Nope, that's not the problem. If I remove this. Right. I can't find data maybe. Alright, let's just Google this. Haskell, Cabal, not in scope, get filled. Showing results for get. How do you get any part of Haskell to work? Yeah, the pain. I wonder if I'm missing a dumbass package or something. Hey Penguin Operator, welcome in. At the moment we're trying to get a program that I've mostly written off stream to compile because this is a different machine. I wrote it using this micro Haskell, which by default has both a bunch of extensions turned on and a very slightly different prelude. So I'm trying to get it compiling with GHC. And it looks like we're missing a few things for some reason. And I don't think it's because we're missing one of these. I don't think. Do we already have duplicate record fields? Yeah, we do. Maybe I can just copy paste this entire list. Maybe that's the way to go. Okay, that's not so bad. In fact, that's pretty good, actually. Okay, what is this? Alright, so maybe I need to add commas. like that. Nope. Okay. Unexpected. Oh, okay. Goodbye. Requires type lists. Type lits. Okay, can we get rid of that one? Type arguments. It's not looking good. Named defaults. I might just try and get micro Haskell working at this point if too many of these things don't work. And it looks like a lot of these things are not going to work. Liberal type synonyms, goodbye. Import shadowing, goodbye. GA, really? Okay. Rebindable syntax is required. Alright, we can do that. Rebindable syntax. Nah, now we're just back to where we were before. Okay, it might be easier to try to get micro... Not in scope from integer. Fuck. Alright, we'll just try to get micro Haskell working. I think it's probably the easier of the two options. So what are we going to do here? I guess git diff. What have we changed? Yeah, we can just git reset hard origin Haskell. Okay, let's see if we can get micro Haskell working. It's just going to be quicker than trying to make GHC work. Even though it takes forever to compile. Not to compile itself, but to compile other programs. Compiling itself is not too bad. I don't... What do I need? I think I need a C compiler maybe? Yeah, we'll take all these. Not that one. So we'll need to get GMP, that's fine. Prefix. Probably... probably that. CC will just be Clang. Okay, this might be enough. Possibly. Yes, so we're going to need more than that. We'll also need GMP, and we might need GHC as well. Okay, can we just make this? It looks like we don't have GMP. Why not? Looks like we should. Package config. We don't have package config. Jesus, gotta do everything yourself, don't you? Where would we find this? Probably wherever want GMP is? No. Okay. LM. I see. Yeah, okay. This is written for his MacBook, so where are our libraries? Is it just lib? No. What is under user? Apparently nothing. Just bin? Okay. I mean, the correct way to do this is to do it in a Geeks module, to make a Geeks package out of it, but I do not want to do that right now. It's under Geeks profile. Yeah, we can go Geeks profile, then under lib we should have, yeah, we'll have libgmp under here. Okay, so this will be under home Despero Geeks profile lib, and this will be home Despero Geeks profile include. That should do it. Okay, brilliant. Do we install it? I didn't want it installed there, but okay. Didn't I change the prefix? Why has it just ignored me? I love it when software ignores me. Yeah, it's Moscow ML. What the hell's this? Interesting. Alright. What are you whining about? Unknown MPZ. Did it install there? It didn't. Cool. Cool. But it did leave garbage in my home directory apparently. Despite me. So I can show you what it looks like. This is an example of what I want it to look like. This is in the raw form. I kind of want two forms. I want this very raw explicit form, which you need to type out kind of everything yourself. And then I also want to add on top of it a simple macro system, because doing basic macros with S expressions is really easy. So I want to add a basic macro system that makes you know, defining things easier, so you don't need to do the whole dance of claiming something and then defining it. Lisp jump scare, yeah. Yeah, sorry, trigger warning. Lisp. Welcome in Neo-Angelism. So this is an example of what I want it to eventually look like. This I can currently parse and not type check because I haven't written the type checker yet. That's on the list. But I can partially type check for a very small definition of partially. Basically, I want it to be a dependently typed language with quantitative types as well, though quantitative types will come afterwards. And right now I'm trying to get my damn fucking Haskell code to compile because Geeks does not have a micro Haskell installation. So I need to do it myself. I wonder if this is enough. I don't know how to do this in... How do I do this in Fish? Is this Fish? No. Or yes? It is. Fuck. I gotta use a more normal environment just so I don't have to spend time on this. Fish export variable. I can't remember why I started using Fish. It's not like I had any real problems with my last shell. My last shell was fine. So we want to add to path. God damn it. God damn it. Alright, gx path equals, we want mcabal bin yeah, 1 second, let me see if this works. Okay, yeah, so in this it's more like a declaration. Claiming something means you're defining a type, so this class variable will have type, in this case type 0. Do I have a better example? Yeah, here's an example. Predicate is claiming predicate is a function type here. It's a function from natural and a proof that your natural is greater than 0 into the naturals. So it's basically just a declaration. And then alias is what does the actual definition. So you could essentially declare. That'd be fine as well. That'd be equivalent. And then define. But I want to use define for something else because I want claim and alias to be the lowest level primitives. But on top of that, I want to build some convenience macros, and I don't want to use like define as a primitive when I want it to be one of the convenience macros. No, I want it to be compiled down to C because the whole point of what I want is I want to be able to write my core like IO logic in C, and then I want to have my application logic to be in the dependently typed language, because dependently typed languages have this problem that they're not sure and complete. Oh, is there? Okay. Oh. Apparently I've used it before. Okay. And so if I try mcabal on this, okay, it doesn't like that. Mcabal. Oh my god, this is such a pain. I almost wonder if it's easier to just write the geeks function. Doesn't like that easy either. So it actually failed to build though. Why was that? Oh, hang on, I'm in the wrong directory here. Fish, add path. Oh, it's already in the path, okay. It does it across shell instances, that's interesting. Nope, still doesn't like that. Do I not have libgmp here? Maybe I don't. You know what, let's get rid of libgmp. This is just causing problems right now, and I don't really care at the moment. Get rid of that. Get rid of these. We probably can get rid of this as well. Okay, so that built. Can I make install? Will that work? Again, it's ignoring my installation prefix, which is great. Taking its sweet time. I did indeed put my installation prefix somewhere else. Okay, what now? Make old install. To install, use make m install. This will install it in mcobal in the same way as mcobal would have. You'll have to add this to your path, that's fine. M install, you reckon? You know what, I may be missing submodules. So I know it has a couple of submodules that it makes use of. In particular for the C preprocessor. Yeah, I was missing a couple of things. Right, that's probably my problem. Can I unset? Maybe, I don't know if that did it. Yeah, okay, looks like it did it. I just wish it didn't take so long to compile. Yeah, virtual names table, kind of, because it's not interpreted though, it's, you need to keep track of that during compile time, like ahead of time before you write it out. And I also want to do type checking, so it's not enough just to register the name. You need to also, well, I guess you could. I guess you could do type checking at interpretation time. There wouldn't be anything wrong with doing that. Okay. Fuck off. CC failed, probably because I don't have a compiler. Yeah, okay, can we do it up here then? Do I have a compiler? Most concerning. I do have GCC, but I don't have CC. Yes, I also don't need any of this anymore. There we go, now we have CC. Okay, okay. Can I run it? First, can I clean up all this crap? Let's get rid of all of this. I don't want this, I don't want this, I don't want this. Yeah, just delete all of that, and I'll try again. Okay. Alright, so can we run this? Probably under bin. Okay, brilliant. We have compilation. Build. Now we can actually work on the damn thing. Alright. Let's get out of here, go back into our type checker, because that's what we're working on at the moment. Alright, so unimplemented normalize, and that's from column 14. Yep, so we don't do any normalization at the moment. I believe it is the whole normalization function is just unimplemented normalize. Yep. Okay, so where do we start with this? Okay, well, I guess we're going to start with a switch case, as we do with all these sorts of things. So we'll go case item.term of, and the first one we're starting with, I think this is a function call, or do I parse that separately? I should parse that, right? It should be a primitive operation. It is, okay. So we'll need to go p.primop pop case pop of p.type, and this is the type level. Now the question is, what do we want to do here? We can go error here, item.source unimplemented normalize primop. And this can be the final case, like that. Okay, so what do we want to do? How do we normalize this? I think it's just level word. I don't think we need to do anything special here. I think levels are going to be a primitive term. I think these might be the only primitive terms we need. Yeah, I think type levels have to be primitive. So I think when we normalize this, we're just going to turn it into level like that. Not quite like that. Return right. Like that. That should be enough to normalize that. There's nothing else we have to do. Okay, cannot satisfy constraint. 57. Term primop. Okay, so the problem with that one was that I have tabs, not spaces, so the alignment was off, and Haskell is alignment sensitive. But now we got a new problem. I wonder if it's better to put the return up here. The only thing I'm concerned about is I think when normalizing some of these, what did I do here? Yeah, because when normalizing some of them, you want to be working inside... do you? So this one is working inside the ST monad. Yeah, so this already returns a result in the ST monad, so you don't want the return to be at the front. Yeah, so I think we don't want the return to be at the front, because I think we'll have the same problem, where some of the computations we want to return in the ST monad anyway. So yeah, we'll just keep the return in here, that's fine. Alright, index out of bounds, that's great. It's a great error as well. What would be the problem here? So one of our arrays, probably not the hash map. Yeah, probably not the hash map, because our hash map has an initial capacity that's large enough to fit this in there. Because what we're expecting is we're expecting to do this correctly, and then when we get to this one, we failed on the fact that we don't handle schema. We could be failing on looking up class though. That's possible. Ah, no, we don't handle alias either yet, I think. It's just claim. Yeah, we don't even handle alias. So we expect to fail on the alias. It's probably not the hash map. What else could it be? Get or put. So we try to put... Well, okay, it looks like the only thing we're doing with indices anywhere here is the hash map, so it has to be... It must be the hash map. So I guess we'll take a look then. Yeah, we do have an initial capacity. 0 to 6. I wonder if this is a problem. Okay, that is a problem apparently. I'm surprised that the array constructor keeps pulling indefinitely from this list. It doesn't just pull this many. But okay, sure, we can bound the size of the list, that's fine. We do that here anyway, so it's not really a problem. Yeah, I do actually want to change this back. Whoops. Just because this line is too long, which is something I want to do something about. Yeah, that should be fine. And this becomes hash map buckets cap len. And then this can just be capacity, this can just be buckets. Okay, yeah, unimplemented primitive, yep, good, that's what we expect to have happen. And we didn't break anything with that tiny refactor? No, cool, so we're still failing on the alias. Okay, so now we got to type check aliases. Let's go p.alias, name definition, I guess. And do we want to do basically the same thing? I think we maybe want to do basically the same thing. We want to normalize whatever the definition is. That's definitely true. Yeah, I think the main difference is instead of putting type here and putting in types, we just want to put in values. Other than that, yeah, and we want to change the error message. No, we want to also check that the type has been defined, because in the kind of lowest primitive form without any macros, I want it to be type declared before defined. I don't want to be able to mix those. Just makes it slightly easier. You don't have to have a list of like undefined terms that are waiting on definitions or waiting on type signatures or anything. And I don't think I can be bothered in this language to do type inference. We'll see. Every language kind of eventually gets a little bit of type inference just because it's kind of a pain not to have it. I think even C has type inference now. C type inference, auto. Did they repurpose auto? Because that used to be a register allocation thing. Let's just go C type inference. Keyword. C++ certainly has it, but you know, C++ is everything, right? So this is C++. C++11 auto. Right, but that's C++. I don't know. Maybe it does, maybe it doesn't. Yeah, every language ends up getting type inference. So we'll see if I add it at some point. But for now, I don't want type inference, and I don't want reordered declarations. You have no choice? Yeah, well. I don't know how I feel. Oh, this one? Yeah, I've seen this one. I think I read this paper, though it's been a bit of time. But do I need to do inference though? Regardless of whether, like, this is fine. But if I don't know the value for a type, can I not just error? Regardless of whether I'm trying to unify. Yeah, I don't know if this implies I have to do type inference implementing this algorithm. Like, strictly, can't I just do an error if I can't find the type of an expression? I don't know, maybe it's easy, it's an easy extension just to go from implementing this to adding type, to having the compiler fully support type inference. Also, I love the naming here, that's great. Yeah, we'll come back to this. Okay, so for aliasing, I'm going to start by just copy pasting this. In fact, I'll copy paste this as well, and then we'll edit it. So firstly, we want this to be values. We want this to be value, duplicate. Yeah, we'll duplicate definition of value. Previously defined at. And now the only other thing here is we want to check if it already has a type. Yeah. We want to check if it already has a type, and if the answer is no, then we're just going to compile our error. What is this? This is in the st monad. It'd be nice if I could chuck it in here, just in the little either snippet. What's the easiest way of doing this? So I don't want to actually normalize it if it doesn't have a type. There's no point normalizing the definition if the variable's not typed. It's easier just to check if it's typed first. I don't want to have a big case statement. Just seems silly. There might not be a better way of doing it. Okay, let's bring this down. I'll remember that's there. So we need case, and this will be hm get. No, I don't want to do a put. I just want to do a get types name of. And if we have nothing, then we error here, item source, attempting to define undeclared variable, I guess, or value. Value with no declared type. We might even just put that down there. And for clarity, do that. Okay, and then if we do have a type, then I guess we'll do this. Ugh. Okay, so then if we do have a type, we do this, and in this case, we normalize. You know, it might make sense to put this before the normalization as well, just because if it's already defined, we don't want to redefine it. I'm not going to allow shadowing, or at least not for now. Especially at the global level. We'll deal with that problem later. This can just get a to-do. To-do normalize after the check we haven't defined already. It's not really the most important problem to solve right now. Do refactoring off stream. Yeah, so we need to alter the values map, and then we need to return, I think an item, right? Yeah, name, type, and value. So we have all of those, so we can return them now. What did I just do? Okay. This can be item. I think that'll pass correctly. We're about to find out. So yep, name, type, yes, type and value, which we can do here. Right, and we update the value map. I think that's what we want. Right. I gotta just expand my tabs so that I don't have to keep fixing that. Okay, that wasn't the problem apparently. Oh, I accidentally deleted something. I think tagged. Oh, right. Yeah, it was just underneath. Bring that back up. What the fuck happened here? Oh, I think I might have accidentally had multiple cursors, and so I was editing multiple things at once. Okay, that'll be annoying if there's a bunch of these things left over. Okay, there might be. Okay, yeah, a lot of stuff is accidentally being deleted. Yeah, and it looks like I do have another cursor selected. Alright, are we back to normal up here? Yeah, we got the array back, we got the value back. Okay, cool, we're back to normal. What are we doing? We're doing the alias. Okay, down here. This will be item, name, type, value. And we just need to change this to be value. Okay. Undefined value st, is that right? Right. Do I do this whole thing in the st monad? I think the answer is probably yes. I think the answer is I have to, because I have to read from the state. There's no way to get around reading from state up here. And then I'll have to do another read down here. Okay, I guess that whole thing has to be in the st monad then. I guess we could do it like this. We could go read stref str and then nope, cannot do it like that. But I can do it like this. Can I bring that back? Apparently not. Can do it like that. Okay. So this whole thing is in the st monad, so I'm gonna have to return. And then this is the st monad again. Do I need this do? Yeah, I do. I need the do. Cannot satisfy a constraint, has field values state. Is it just vals? What did I call it? Terms, sure. Actually, can I change this? Values. No, I actually like terms better. I'll keep it as terms. Cannot satisfy constraint either non-empty item. Yeah, true. That's I could just chuck it in a do, whatever. It doesn't cost anything. The bytes are free. Cannot satisfy constraint item tagged. Column 50. Oh, should it be normalized? Did I not normalize it anywhere? I did normalize it. So it should be tagged. Yeah, so this should be a tagged. Oh, it's not. It is an item. Yeah, true. Yeah, I guess I want to take them out of this because these ones just indicate that I'm not yet fully finished with a name yet. Either I only have a type or I only have a value. Though, to be fair, I don't think I should ever only have a value because currently I'm not going to allow out of order declarations and definitions. So I should only ever be dealing with this one, which signifies that I have a type but I don't yet have a value. This one should never exist. For now, at least, the way that I'm structuring the language at the moment. We'll keep it in, maybe for later. Alright, we got a lot of languages going on here. I don't know what this is. Why am I doing it in Haskell is sort of the gist of this. I can't translate this one, so we'll Google Translate that. Yeah, why am I doing it in Haskell? Yeah. So I wanted to do it in something that was ML descendant because they have very good support for pattern matching, basically, which I make use of pretty frequently. For instance, if we open up the parser, so this isn't everything. Yeah, this isn't everything, but these are some of the primitive operations, and you just want to have this this enum, I guess, if you want to call it that, or this sum type that has all the different kind of primitive operations you have. And then later when we're type checking, so this is the output of the parser. Later when we're type checking, these ML type languages have good support for. Yeah. I got that it was some mixture of German and something else, and maybe German with a couple of mistakes. But yeah. So yeah, they have good support for this sort of pattern matching, which I thought would be very helpful, and so far is helpful. It's been good. I don't really have complaints. I originally started writing it in standard ML just because GHC, which, you know, Haskell is kind of, Haskell and OCaml are the preeminent ML descendants of sorts, although Noshk. Haskell comes through clean, which I don't know. I'm not fully sure. Let's just find that out rather than me making stuff up. Influenced by, well, okay, this is not super helpful. Miranda. Yeah, Miranda sort of vaguely comes through ML as well. Yeah, so Haskell and OCaml are kind of the most prominent ML descendants. OCaml was a strong competitor for me, but I couldn't get it compiling on the machine I had at the time. I can't remember what the problem was, but it didn't compile. So OCaml was out. Haskell was another option I was considering, but GHC June fucking sucks. Yeah, I have mixed opinions on June. I don't hate it, but it's not. Yeah, it's not incredible. It's certainly better than Cabal used to be. Maybe half a decade to a decade ago, I was probably closer to a decade ago. I was trying to use both, and look, June was a lot better than Cabal was at the time. But Cabal looks like it's come a long way. Even this tiny little micro Cabal implementation from, I think it's from Augustus, whatever his name is, microhs. This guy, Augustin, Leonard, that's his name. Even his little micro Cabal, yeah, it's pretty nice these days. It's a lot better. It probably didn't help that I was using Haskell on Arch Linux, which has really fucked up Haskell packaging. The maintainer of the Haskell packages lives in like rural Portugal or something, and his internet connection sucked, so he couldn't upload giant static binaries. It was just these dynamic libraries, which does not gel well with Haskell's ecosystem. So it probably didn't help at the time that I was dealing with Arch Linux Haskell fuckery. Portugal. I think it was Portugal. It was somewhere in Iberia, rural Iberia. So, like, mad respect to the dude living out in rural Spain, rural Portugal, wherever, and packaging Haskell software for Arch Linux. I got no hate against him, but it was a pretty shitty experience as a user to try to make the Haskell ecosystem work on Arch Linux. But yeah, the biggest problem I had with GHC when I started this project was that I just couldn't compile it for the machine that I had. GHC is a massive pain in the ass to bootstrap. If you don't already have a prepackaged version of it, basically give up. It's just such a pain. I mean, you can do it. You need to go like hopping through the oldest version that compiles with GCC and then compile a newer version and then use that to compile a newer version and so on. I just couldn't be bothered. So I originally started this project in standard ML, and I still have some of that lying around. Probably on master, I guess. Main.sml. Yeah, here it is. Still lying around. And the reason for standard ML was it has a lot of implementations, and some of them are very easy to compile. In particular, Moscow ML was very easy to compile and get running, since it's basically just written in C. So I just need to C compile. But then I learned. So I already got rid of it. Then I learned about this. So why did I switch? That's maybe the better question here. Why did I switch? Standard ML has a few annoyances. I don't hate standard ML. It's a decent language, but there's a couple of things about it that's annoying. One is updating records. You have to update every single field when you update a record, unless you use a compiler extension. You don't understand, you don't use them. I'm not get that. But yes, so standard ML, well, that's one annoyance, is that records, you need to update every single field. So if you add a field to a record, you need to find every place you've updated it and then update that part of the program. Another annoyance is that it doesn't have good support, or really any inbuilt support for monads. And monads are super useful especially when you have this paradigm of, do I have a good example here? This isn't a great example, but when you're using things like the maybe and the either monad, and you want to be able to just sequentially do a bunch of things and not have to worry about checking if each one succeeded. If this fails, this is in the either monad. If this is a left, it just won't do anything afterwards, right? Like, that is super convenient to have. This is not a great example of it, to be honest, but being able to just sequentially, in terms of in your program, right, you're typing code, just line after line, say do this, do this, do this, do this, and the type system just takes care of the fact that if any of them fails, it stops, is very convenient. And so that's why I decided to switch over from the standard ML version to the Haskell version when I learned about this, which is very easy to bootstrap. It was a little bit annoying, but you know, we did it at the start of the stream, got this thing compiling. Yeah, I don't like using Rust, to be honest. That's the short answer to that. Like I'm not a Rust hater, but I just think it's kind of an average language. I don't think it's incredible, and I don't particularly like writing it. So I try to only write it when I have to, which is, you know, usually at work or something like that. But yeah, I thought about this as well. Certainly it's, you know, the match and the enum in Rust certainly give me the sort of things that I was looking for. But yeah, just personal preference. Oh, and also it's hard to get bootstrapped because it's an LLVM thing. Right now I don't have a practical use for bootstrapping, but you know, like every programmer to have ever existed, I have in my mind at some point in the future writing an operating system. I don't know if that'll ever happen because, like every programmer ever, it's a much bigger task than they think it is. But I want to be able to bootstrap what I have on a new platform, and Rust is very difficult to bootstrap. Anything that builds off LLVM is quite difficult. Whereas micro Haskell is, again, it's basically just C. Modulo a few details, but it's essentially just C. So it's quite easy to get running on a new platform. How's the Norwegian coming along, by the way, Penguin operator? I see you're just kind of throwing out a lot of different languages in here. What did you write up here? English, Norwegian, Dutch, and sorry, not Dutch, German and Latin. My Latin's even weaker than my German, and my German is not strong. Okay, what is it complaining about? That's fair. I guess Latin is Romance, right? But I guess it's more similar to the Germanic languages than it is to, I don't know, Chinese or something. Item is not tagged. Right, yeah, this is what we were on before. We'll do val. And where is... Yeah, this. Do we use this anywhere else? No, just these two. So we should be able to just go tagged and then grab that. That should be enough to unwrap them. Term does not with tagged. Oh, we have the opposite problem? Oh, right. True, so true. We could actually just skip that part and just do this. There's no reason we can't do that. We don't need to tag it in that case. No, we do need to tag it. And we do need to put it as well, because it needs to go in our dictionary of... Oh no, we can do that. That's no problem. Then what was I doing down here? Why did I wrap this in a type? I think this is probably not correct. Put case res. put. No, that's fine. Okay, no, we're good. Yeah, like all good programmers, you have your own programming language as well. There's something just irresistible. It's like gaming, operating systems, and programming languages. I don't know. It's like the siren call. Every programmer gets drawn to them. Do you have any code samples? I know Penguin Operator started a project as well for a programming language. But do you have any samples of how your language looks or will look eventually? I want this to be tagged. Right, but this is tagged? Yeah, this is tagged. So actually, I want it to be like this. Yeah, there we go. Okay, and so we got all the way up to here, which is the schema. Okay, brilliant. And it's true, we haven't normalized schemas. Those schemas are already normalized, so we won't have to do much for that. Oh shit, I forgot about this. Do we need to do anything about that right now? Yeah, okay, cool. I mean, hey, just an ML. If it ain't broke, don't fix it, right? ML works pretty well. I haven't taken the time to read about these. I know OCaml has popularized them by actually using them. But I haven't really taken a look at this. Yeah, this is all JavaScript syntax. I don't really know what the TLDR of algebraic effects are. Do you mean your writing style in Russian as well? Because that's your native language, right? How good is your German, by the way? So you're just sort of learning now-ish Norwegian, but are you able to write natively in German? Unison. Yeah, I'll be able to spell one day. It's not today though. Right, all the stuff that Haskell would put into IO, for instance. Yeah. Oh god, try catch. Fictional language. And then resuming the program. Process of doing something which should continue after the call to log. Okay. Oh, relatable. Doesn't exist. Is this true? Are they trolling me? Is this what Unison looks like? Just like a try block is followed by a catch, imagine the log block is followed by a generic handle whose job is to pattern match on the possible actions log can do. I see. I see. So you do a bunch of stuff and then you just immediately feed it into like a match on whatever the result is. Okay. Interesting. In our fake language. They're laying it on pretty hard. The handle looks different. Let's think about what a handler should do in response to a put. We want to grab the key and value, update them, resume the remainder of the program. Okay, yeah, I could see how that would be useful. Updated put and then resume with the updated, yeah. Is this substantially, like, is this a substantial improvement over what already exists? Like, I'm not sure where I would be very happy to have these over what already exists. This is maybe a little too, it doesn't do enough comparisons. So it's like, it's continuations and pattern matching, I guess. What makes the continuation types? I presume it's type safe. Yeah. True. We could write such code. Having this natural evaluation order and trying execution to evaluation. Tying execution to evaluation is not the same. In the same way, it's not an option in Haskell. Haskell is non-strict. In a similar snippet, A and C are never used nor evaluated. Yeah, sure, fair enough. Yep. Yeah, following. Yeah, I kind of agree with this. This is sort of what I was mentioning before with the either monad in particular, where you get the early exit from anything that fails. It's very nice. Okay. I'm gonna sort of skim through this because this is, yeah, it was just explaining to me. Yep, that's fine. I can skim through that. Okay, the costs. Let's not lie to ourselves. I'll try. This is not the nicest snippet of code. Yes, don't do that then. Use the do notation. Yes, use the do notation. We already know how to resolve this. Okay. Wait, they're saying that the cost of monads is if you don't use do notation, then it's ugly? I guess the cost of do notation is that people who are new to the language don't understand it and it's too much magic for them. But I guess you don't, you know, should you write a language that's aimed at beginners or aimed at people who know how to use the language? And that's a sort of fair question. All right, let's keep reading. Oh my god, we're only halfway. Okay, we're gonna have to try to skim through this. So we can get back to programming. Arbitrary user-defined effects. That's 3 thumbs down. Oh god. Teachability. Syntax is ON. Each feature requires custom syntax. Oh shit. Not typed. Okay. The worst of both worlds. I do like that. The worst of both worlds. Let's do it. The best of both worlds. Okay, so Is this just syntax? I'm not sure I fully understand yet. Can this be mechanically transformed back into monad form? Or is this something that's actually different? Like, are there cases where you cannot transform this into a monad? It's just a nice interface over delimited continuations. Well, okay, I don't think... can you have continuation monad? I'm not sure. Can you do that? I guess so. So I guess you can do continuations with monads. Direct style custom features, the compiler does that monads. We manipulate the data structures that reify the call stack. We use user level primitives to affect the call stack, but it's quite mind breaking. Yeah. We use delimited continuations via better interface types and syntax. I don't know. How old are these? Are these new? Because I would kind of want to see what, after, you know, maybe 15 years of this being in actual use, was it worth it? I don't know. I would have to use this. This seems like a kind of minor improvement. It doesn't seem major. But we will get back to programming after I get up a Wikipedia page. Oh, you can do effects in Haskell. Interesting. Okay, we'll get back to programming. But yeah, okay, it's interesting. I'm not sure I fully get it yet. If it's something major, it's like a shift, or if it's a sort of minor improvement rather than a seismic shift. Cannot satisfy a term tagged. Yeah, I agree that they're different, but which one are you whining about? 45? This one? Type? This is get, so it should be getting a tagged. Yeah, it should be getting a tagged, and we want to give a tagged, so what's the problem? Case hm get st types. Yeah, from st types get name, and st types is indeed tagged, so we should be getting back a tagged. So it wants it to be a term? Surely not. Item is tagged and tagged. Oh, we don't need to... Wait, no, we do need to tag this. Wait, do we? No, we don't need to tag this. What did I do? What's going on? Oh, that's what's going on. Okay, there we go. Yeah, if we're already returning the tagged one, we have no need to retag it. Tagged... No, I'm dumb. I keep confusing myself. We need to put all that back. Okay, so definition. Definition is a normalized version, and normalized should return a term, right? Yeah, normalized returns a term. So definition is a term, and then we tag it, as in just add the source information, and then we put that into types. Oh shit, this is in types. I'm in the wrong place. Okay, back here. Yep, tag it. We're into terms. Okay. Terms is tagged. Yep. So we put it into terms, the tagged version. Yep. And then there we return both the map that's been updated and the tagged version of it. So then after we do that, if we got the map and the value, do that. The terms map gets updated to be the new map, and then we do this. Oh, ah, fuck, I was looking at the wrong place. Okay, I was too busy reading this error message when it actually just works. Okay, all right, schema time. So primitive op, rather than p type, we need p schema. And what does the schema have for us? Params, indices, and primitives. Yes. It's a great question what we do about this. I think the correct answer is nothing. I think a schema should normalize to itself. If you imagine, where's a good example? Yeah, so if you imagine wanting to know, is the type just 5 the same as just 6, right? Or I guess strictly this is maybe.just is what we're doing. Maybe.just. How do you want to do this? I think yeah, I think you want to expand this out into maybe.just is a primitive 5, and this primitive has yeah, it's a primitive with, okay, this is a bad example because in this case you're just going to be checking this, where this primitive is like, it's the primitive maybe.just, and this primitive is also the primitive maybe.just. So I think this is a bad example. This is not the one we want to look at. What we want to check is we want to check if the types maybe nat is equal to maybe and then int or something, some other type. So when we expand out maybe, I think we do just want to expand that to be schema. Now a great question is, I'll read that in a moment. The great question is, what do we do here? I think we only want to take the parameters. I think the indices, no, we want to do them in order. We want to start filling out parameters first and then start filling out indices. Is that true? Yeah, that's true. So we want to do schema, and then we fill out the first parameter with nat, which means we go find every instance of A, and then we replace A with nat. So I think we just want to keep this the same. We want to go schema, maybe nothing, maybe nat, maybe just, nat, maybe nat. And we want to test, is this equal to this? And then when we test if these are equal, we check if the number of primitives are the same, and for each primitive we check if the primitive what are we going to do with the primitive? Because if we're saying our primitive should expand into primitive, like this should expand into like primitive maybe nothing. Maybe what we should be doing is we should be doing this instead. And then these expand. Yeah, and then maybe this expands into like primitive, maybe nothing. And this expands into primitive, maybe just nat. Yeah, I think that's how we want to do it. But either way, I think we want the schemas to normalize into schemas. I don't think we want to reduce these any further. Like schemas should just be schemas. There's nothing wrong with that. Yeah. I think it's only... Yeah, I think all primitives should normalize down to themselves. The benefits are that you write code in normal direct style, no operator hell or need for custom do notation. Sure, I mean the operator hell, especially when you start going to like the big lenses, the big lens library, yeah, the operator hell, definitely you see it. Custom do notation or transformers, okay. Effects are composable without lift hell. Right, yeah, I mean that's fair as well. You do need to do a lot of like map M and lifts and all that sort of stuff. Yeah, okay, that's fair. They just union by default. Stream AIO exception. You can swap handlers to give the same code different meanings. Save to in-memory on dev versus DB. Okay, okay, fair enough. Algebraic effects are good enough. They're much easier for me to reason about. Yeah, that's fair. Okay, no, I can see the benefit. I think this is definitely fair. I don't know if I'd call it hell, but I definitely understand what you mean. Like, fair enough. Operator hell, I think that's how would I phrase this? Maybe some library writers need to exercise more restraint, but in practice you are right, this does exist, regardless of whether it's an issue that's fundamental or a one with restraint. Yeah, okay, I can see it. What was I going to say? Something about Unison? Yeah, is Unison used, or is it a research language? Because my main problem with research languages is they change too much. And usually they don't focus on the parts of the language that I think are good, because from a research perspective, it's already done. Like they need to move on and do new research. And they're constantly pushing the language in directions that I think are not super useful. So what I'm curious about is if this language is a research thing or if it's meant to actually be used. Meant to actually be used. Desktop app. What is this? Oh, they have an editor? Okay, it's probably not research language though. If someone took their time to build an editor, this looks like it's meant to be used. Ain't no academic got time to do this, dog. It's a 0 point something. It's not done yet. Unison web. Interesting. Is this the website? No, because it's got this as well. Oh, this language. I've seen this language before. I didn't realize they had algebraic effects. I might check this out at some point. Records. Yeah. Yeah, records are important to get right. Okay, that's cool. I'll check this out at some point. I don't think today, but I'll see if I can get this compiling on my various machines. That's a lot of languages are ruled out because I can't get them compiling on whatever machine I'm using. Oh, it's written in Haskell. Okay, interesting. This isn't though, right? No, this is written in Unison. Oh, does GitHub just not know what Unison is? Yeah, okay. It maybe just doesn't know what Unison is. Oh, no, maybe it is written in Haskell. Oh, it is written in Haskell. Okay, fair enough. Okay, cool. I'll close this. I'll remember what this is for sure. We'll close all this. I'll remember all of that stuff. Right, so what do you think your language will add on Unison? Because I know Unison, they mentioned they have this content addressable code idea. Do you want to take that away and just have a more normal programming language just with algebraic effects included? We don't need this anymore. We don't need this either. Okay. Yes, I'm going to copy this. We'll come back to this. Schema, yeah, this is not enough. Yep, fair enough. Okay. I'm all for more languages. I know some people, well, I mean, I'm writing one, so I must be. I know some people are pretty hard on when someone says, I'm going to write a new programming language. It's like, why? But I'm all for new programming languages. So good luck. Hope it works out. Is this right? Params? It's not quite items. Is items correct? I'm not sure items is correct. No, it is. It is correct. So let's go back to our example program. So our schema. Oh, it's interpreted. Is that how they make it work? Interesting. Yeah, I know I've heard about this, but I don't actually know how it works precisely. Where's vector? Here's vector. Here we go. So A. Do I want this to be an item? I think the answer is yes. And the order is important, so I can't just chuck them in a hash map, because the order is used when you instantiate it. Yeah. Vector AN, the order does matter. So I can't put it in a hash map. So I think what I want is I just want an array of, yeah, an array of items. I want a name, type. Definition. That's an interesting question. Maybe I don't want an array of items. I just want an array of types with names. Yeah, I maybe want an array of this, which is an item. This gives much to think about. Maybe I want to go even simpler than this. I just want to go text and tagged. That's probably enough. So we have the name and the definition. I think that's correct. So these are the parameters, and then I want indices, which I think are just exactly the same. There's no difference between the parameters and the indices. It's just how they can be used, right? Which during type checking we'll have to make sure is correct. Ooh, that's going to be a question that we'll have to come up against, how we have smaller environments, because we'll want to add A to the current environment but delete it afterwards. I think that should be okay. We just need to create a new, yeah, we can just create a new hash map and throw it away. That should actually be fine. Right. So the editor is like an important part of the language. You can't really skip it. Or can you write it in a text editor and then ask Unison to put it in the database on the command line? Why did they do this? Big idea. Okay, yep, understood, but why? Okay. It simplifies distributed programming. Okay. As in you can just send code across a network easier? Is that even true? Because it's a hash. You have to send the code anyway. Does the hash really help you? Oh, you can send RPC calls maybe? To say run this hash, and then it can look up the hash in the database. Okay, maybe. I don't know what that means. Yeah, sure, fair enough. Yeah, maybe, I don't know. Lots more, okay. We created this. Sign up for free. Okay, I'll come back to this later, but let's look at this. Arbitrary computations can just be moved from one location to another. Yeah, as long as everyone has the definition, sure. Missing dependencies deployed upon the fly. Okay, I don't know how you do that, but sure. The sender ships the bytecode tree to the recipient. Yep, understood. Expects it for hashes. Uh-huh. Okay. Yeah, so remote procedure calls is the obvious one. It is a freeing thing. I'm pretty sure you could do this with a library, but sure, it's nice that it's built into the language. I'm not going to claim that good libraries exist to do this. Out of band. Okay, I think they may be slightly overselling it. Like, somehow this is magic. I mean, the Unison runtime does all this for you. All the stuff it says, like, you don't have to do this, is just because Unison does it for you. So they may be slightly overselling it, but okay. It's a very convenient library to do remote procedure calls. Okay. Okay. Alright, so they have a better way of referring. Yeah, okay. This looks like a lot of tooling, which is valuable. Like if the language's big idea is that they wrote a whole bunch of tooling to make all these things easier, that's fair enough. That's still valuable, even if you could do this as a library in another language. Ultra minimalistic. Yeah, have you been working on this? You linked this? No, you linked this last week, but it's still in progress. Yeah, C, to be honest. I use C for scripts. A lot of people, yeah, a lot of people sort of scoff at that, but to be honest, other than string handling, C is a great little language. It's quite easy to write scripts in it. And if you need to do string handling, then yeah, I try to use a different language because string handling in C is kind of a pain. But other than that, it's fine for scripts. Alright, so we have parameters, we have indices. I tried using a different language for a while. I've tried using Python and I tried using Racket. It just didn't work for me. Python because I actually just don't like Python. And I don't like writing it, so it was sort of a mental issue rather than anything else. And Racket was mostly fine, but everything was just like a little less reachable than in C. I would sort of break the task down to precisely how I wanted it to work. Whereas in Racket, I spent a bit of time looking up how does Racket do this precisely. You know, there's a Racket function to do something. What is the exact way that this function does it so that I can compose it with another function? Whereas in C, since you have to do it yourself anyway, when you break down the task into these are the steps that I want done, you might as well just implement them. I guess these are just terms. What's a primitive? It's just a bunch of terms. Should it have a name? How am I going to keep track of my primitives? Probably with the name, to be honest. I think that's probably the way to do it. Is this the right thing? Is this what we want? I guess this should be tagged as well. Is there any reason to do it this way rather than having one big array? Yeah, I think there is, because when you encounter a definition, you want to check, when you encounter something like maybe.just, let me think about this. Because maybe.just, when we encounter the schema, we're going to both record the schema itself and record all the primitives, because we want our code to be able to use maybe.just without referring to the original schema. Like over here, nope, over here, yeah, we want to be able to type maybe.just without having to also have a copy of the entire schema for maybe. So we'll have to record maybe.just as a primitive in our types and terms, as well as recording the schema itself. Do we need to track primitives? I think we should. I'm just trying to think, what would you use it for? Oh, we'll use it for compilation. That's actually a good point. Yeah, we should definitely track primitives then. We'll probably use all this information for compilation. Yeah, okay, we'll track primitives then. Yep, keep them around. So we'll get rid of this. Okay, so let's find schema. Where is it? Is it type checking? No, it's here. Is this right? Should it be in type checking as well, or just in normalize? I don't think it makes sense to type check a schema. Schema doesn't really have a type per se. I guess it does. I guess it has this type. Yeah, I guess we should type check the schema then. We should make sure that it has a type that's compatible with this, because the type of this schema is type A, type 0 to type 0. Yeah, okay. Yeah, we should type check the schema. Which involves just checking the indices and the parameters. Yeah, it involves taking the parameters, checking that they match the type, and then the indices. And checking that the type levels match. So you can't have something like that, or I guess the alternative, something like that, is not allowed. Yeah. Have we not type checked a function type yet? No, because we're only up to here. No, we're not even up to here, we're up to here. Okay. Yeah, so the first thing we want to do is we're going to type check that the schema is compatible with the claim. We should only be normalizing terms that are already declared. Ah, no, how do you do that? Because at this point in the code, we don't have the original claim or the original alias. We only have we only have the schema itself. Ooh, we might actually have to come back down to the alias and do some more work here. Because we want to normalize. So this will normalize the schema if it is a schema. It might not be, but if it is a schema, this will normalize it. And then, yeah, and then afterwards, what we want to do is we want to type check that. We want to make sure that's the same type as this. Yeah, okay, I didn't actually do the type checking. That's bad of me. How do we do the type check? I guess we need to have equality. Should we do this here? Probably. Something like that, I think. Get the definition, check it's equal to type, and then put and tag it. I think that's the way to go. Or tag and put it, rather. Oh, interesting. Huh. That's an interesting way to display ligatured fonts. Funky. Anyway, yeah, so we definitely want to check that it's equal. I think we'll end up using this a lot. Do we want to call it check equal? That's fine, we can just rename it, it's no big deal. That should be, we'll put it here. And so this, we want to check if two terms are equal, which actually involves normalizing them. Should we only normalize once? Or we can alternatively just say that we will only ever check types that are already normalized and leave it on the caller to make sure that they're normalized. That's doable. Is that reasonable though? Because I don't think type is normalized. What do we do with the claim? Do we actually normalize? We do, so it is normalized. To do. Think about if we should normalize or make the caller do it. Currently caller. So we'll take in two terms and then we'll check if they're equal. Better idea, we'll take in two tagged terms and return a result of if they're equal. Or do we want to return the original thing we got? Because that would make this slightly easier to write. Alternatively, we can do this. Just put return. Yeah, it does. We can do that. Yeah, I don't. Yeah, so I saw a, I don't really use generics to be honest. If I need a hash map in C, I'll just write a hash map for the specific type I need, because you really don't, I just don't use them very often. And also it's not that hard to write a hash map or a dynamic array or whatever. They're pretty easy to write. Namespacing is one that I go back and forth on. Namespacing is nice when you have it. But as someone quipped, rather facetiously, C does have namespacing. It's called using the underscore instead of the dot. The main thing is that you can't rename the, you can't do something like this, right? You can't rename the namespace if you don't like it. And you can't import without the namespace. You have to use the namespace. Is this for your programming language? Is that what you're talking about here? The one that you linked up here? Yeah, like I don't know. I don't really have a problem with C. It's got a bunch of warts. It's missing a bunch of stuff. But when you just want to have an algorithm and implement the algorithm, like you just have a problem to solve, you know how you want to solve it, and you just want the problem to be solved. It's hard to beat the... Oh, I did this up here. I should have done this in the claim. No, the alias is right. It's really hard to beat the convenience, if you want to call it that, of C, where it really does just tell you, write your own damn solution to the problem. Does this need to be... No, because this returns an either, so that's right. This can return a bool. Or just a result even. And yeah, I don't know, when I think about problems, I really like to break it down into what I expect, how I want it to actually be solved. So C is very compatible with that. By contrast, something like, I don't think I care about the name, I think I only care about the type. Yeah, T1. By contrast, something like Python, by way of example, for now we'll just return left. Boo earns, no, it can't be a left. And right, a tagged is not the name, a tagged is source and term, right? Something like Python is, there's a lot of stuff that is automatically decided for you when you try to use Python, and I find myself frequently, whatever, we'll just replay it, whatever. They all sound the same anyway to me, to be honest. Yeah, I find myself frequently having to read source code for the Python standard library to figure out why the fuck my code doesn't work, because they've made some decision on my behalf and I don't know what it is. Unimplemented check equal. And we'll get to that very soon. My code's kind of in a half broken state, I think. We need to do this as well. So I'm not a huge fan of magic. What did I just do? Which is ironic from someone who's programming in Haskell, very magical language. But there we go. Unimplemented normalize schema. Yeah, so I don't like magic, and C has very little magic, which works well with the way that I like to try to solve problems. I guess the contrast is something like C++, which does have namespacing, it does have generics. I guess that's the contrast. I don't know what it is with me and popular languages, but I really don't like writing C++. We need to get rid of this. Too few arguments. Yeah, that should be enough. Too few arguments. You want me to do all of them? Really? Isn't it enough just to have the record? Do I really have to do all of them? I don't suppose you'll let me do that, will you? Oh, you will? Okay. I'll take it. Cannot satisfy constraint term and tagged. Column 39. D is a term. Is D really not tagged? Oh yeah, that's the whole point of tagging it. Yeah, no, it really is not tagged. Oh man, this is hideous. I should just do this in a separate function rather than doing it like this. Can I do this? Oh, this is even worse. If this doesn't work, I'll just pull this out into a separate thing rather than... Okay, well, it did work. To do... Cleanse your soul and fix this garbage. And improve. No, fix will work. Yes, unimplemented normalized schema, I agree. Yeah. I don't know. I think includes fine. Obviously, it's really ugly solution to just copy paste a bunch of text into a file, and then you've got to implement yourself to make sure you don't copy something in twice, and you have to go through all the drawbacks of copy pasting a huge file of text every time you run into an include into your like in-memory buffer or whatever. And if you include the same file, well, I guess you can inline process the C preprocessor, but if you separate out the include step from the if check step, which I don't think there's any reason to do, but if you did that, then yeah, every time you come across an include of a certain file, having to re-include the same file, yeah, it's ugly. I get it. I totally understand why someone doesn't like it. I get it. I don't know. I just don't find that it causes me practical problems. It's just kind of aesthetically unpleasing, or theoretically unpleasing, I guess. It's unpleasing from the sense of, you know, we have better solutions to this now, but I don't know. A solution's only really better if the original thing causes you a lot of problems. And for C, the whole include namespacing thing doesn't actually cause me problems. So the better solutions are, you know, theoretically better, but maybe not in practice better. If I was making a new language, I would include the better solutions, because a better solution is, you know, just better. Just include the better solution. But I really don't have a problem with C's solution to the whole namespacing include thing. Like, it's fine. It works. Although I say that if I was making a new language, I would include the new solution. You may notice I've manually prefixed everything here. I've been thinking about how I'm going to handle includes, and I think I am just going to copy paste the text in. So I say that I would just do the better thing, but maybe I am lying. Maybe I have told a fib, and maybe I will not do the better thing. We'll see. So this is like prims. What else do we have? We have prims, we have indices, and we have, this should be, what do they call them? Params, that's it. Params, indices, and prims. And we need to normalize this. I think there's nothing to do here. I think what I said before is right, and we're just going to... you know what? I think that's not quite true. I think we need to normalize this part of the primitive, because you can use other types in here that might need normalizing. So you don't need to normalize this. You might need to normalize this as well. Okay, so we'll have to normalize all the types, but other than that, yeah, we don't need to normalize the names, just all the types. Okay, sure. So we do need to normalize it. Fair enough. What's the right way of doing this? Probably just mapping. Yeah, I think it's just mapping over the params, because each parameter is, where is it? Why did I make new type definitions for this? But why did I make them all different? Oh, because some of them are different? Okay, let's start with the params. Okay, so it's text, which I guess is the name, and the item, which is the type. So we need to normalize the item, and we can just pass the text through unchanged. That's fine. Okay, so what do we need to do? We need the elements of params. We need to start with that. Excuse me. Rename session. Like that. Okay, so if we're going through params, we need to actually go through params.items, not params. Okay, params.items, like that. Do I want to keep the sources in here? The answer might be yes. Can this fail during compilation? It can't fail during compilation. Can it fail later in type checking? Because the only reason to keep the source information is to print errors. So if it can't fail, there's no reason to have it around. I guess it can't fail later in type checking, but we can have something else fail in type checking. That refers to this. And we might want to put that in the error message, but I'm just sort of thinking about what practical situations that would occur. Like if you did something like, if you tried to write a type like maybe it's a bad example. If you tried to write a type like vect of natural numbers and, I don't know, nat. Right, so this guy here, that guy, he should be an actual natural number, like 5, for instance, right? So it should be vec nat 5, a vector of length 5. So we might want to write an error saying that this parameter is defined here. Okay, maybe we do want to keep it around. Maybe. In which case... Oh no, we do have it because it's tagged. I'm dumb. Also, we don't need the text here. There's no text. They're not named. It's just the type. Okay, we do have it around. Never mind. I was worrying about nothing. Okay, so we get all the items, and then this is just a list, and we want to map... I think map M. Because I think we'll do this in the either nomad. Is there a reason not to? Yeah, looking up new types has to be done in the ST monad. This is lift hell, as was mentioned earlier. We've got to lift all the types. Yeah, it's a normalization has to be done in the ST monad, so this will have to be an ST result. And then we have to lift that to STD's nuts. Okay, let's get rid of that then. We'll just do this in ST then. It'll have to be done in the ST monad. Let's write out what we want. We want... Let me think about this. For each of these guys, which is one of these guys, we want to normalize this guy. One of the things that I'm finding quite annoying about micro Haskell is that they haven't implemented array is not foldable or traversable. So you have to convert back down to the LMs every time and build a new array because it's not foldable or traversable. They also don't have mutable arrays, which is whatever, I guess. Maybe we just want to map. No, we definitely want to map M. We want to turn a bunch of, well, maybe we want to map N to map M. I did something similar to this. I also, we'll keep that up, but we'll make it smaller. How do I make this smaller? Ghosty. Thank you, Ghosty. Okay. Where did this happen? It was in HashMap. Yeah, so we have a bunch of LMs, we have a bunch of LLMs, as it were, a bunch of chat jeopardies. Yeah, and then these are a bunch of, this is in the ST monad. So by mapping M store, we ended up with one ST monad. With the traversable being the list inside. Yeah, I think we want to do something similar. I think we just want to map M to get one ST monad item. And then inside that, we want to be a bunch of either monads. Ugh, this is lift hell, as it were. Okay. Oh, shit. What did I do? Am I just going to call it lift? Maybe. Norm. And what do we get? We get a p.schema param, because they're all different types, so I'm going to have to do it 3 different times. This was a silly decision when I decided to do this. And we'll have source and items. No, wrong. We'll do it like this. Okay, and then we have this item and we want to normalize it. So we want to go normalize str like that. Is that really all I want? No, not quite. Not quite. Yeah, because I want this to be second. And then I want this to be like that. First. I'm sure there's an arrow that can do this. Right, but res isn't either. There's got to be a better way than unwrapping it a second time. Maybe there's not. That would be very sad if I had to do another unwrap. This is a result term. I think I do have to do a second unwrap. What's the right way to do this? You do it like this. And so this is left error. Just give me the... it might be easier to do the return there. So this is left error, so this just changes the type. Do I need to change the type? I maybe don't. We'll do it anyway, it's fine. Yeah, because then I want to go write first iterator res like that. So I want to unwrap the res and put it on the entire, the entire thing. Okay, and then so we want to map norm over this. And so this gives us, this will give us an ST guy, but we're not done there. Because this will give us an ST with a list of ethers. But I want to pull out the items from that. And I want to map M. Just identity? That doesn't seem right. But I want to do this in the ether monad. So then this becomes one big ether rather than a list of ethers. Is this all I want from this? All I want. So then we can, so this is not quite right. This is like params, and this is, or surely there's a better way of doing this where I don't need to have the fucking, this dude. Surely this guy is unnecessary. I sadly don't think it is though. But I can maybe go param items, lms, mapm norm, and mapm id, and return, I guess. Is that actually going to work? I have great skepticism. And also, I think I want to reverse this. I have great skepticism this will return. So this should be mapping in the ethers. So we should end up with an ether. And then this will be mapping like this guy with the ST monad. I have great skepticism. Let's just put a return error here. Item source. Oh no. Alright, let's fix our broken shit. ST is not a list. Completely agree. Where column 44. Yeah, no, that definitely won't work at all. Yep. No, true, very true, very true. What's the right way to write this? Maybe to put that there and do something like that and just take the hit of parentheses. Every Haskell programmer's worst nightmare, writing one single parenthesis. Okay, that does probably do what I think it does then. If it compiles, it works. Am I right, guys? Whatever. So that's the params. We want to do essentially the same thing. I wonder... No, because it would have already inferred the type of norm, and the type of norm will take a scheme. No, that's not true. Norm takes a text item. So we can actually reuse it on the primitives, which are text items as well. It's only the indices we can't use it on because they don't have the text part. So we can actually go prims equals mapm. I mean, we could make this a function as well. Sure. Let's I don't know, what do I call this? What am I doing? Yeah, what am I actually doing? Am I just like shuffling data around? Is that all this line does? No, it normalizes. Norm pair, I guess. We'll take that. We'll take that. Like this. No. Just write the parentheses. Write the parentheses. It's not a big deal. So we'll go norm pair params, and then we'll go norm pair prims. And the question is, how do we write the norm one? It's really this part we want to be different. This part we want to be the same, essentially. Yeah, this part's exactly the same. It's really only this normalization function that's different. The only difference is we're not returning a pair. So maybe this should be norm pair, I suppose. That can be norm one. And this can just be it. Ah, you know what? I don't need this ugly case because I don't need to extract out anything. In fact, norm one is just normalized. Yeah, norm one is just normalized. I actually don't need this at all. So norm one, this is just normalize lms, it's return map m id. Is there a way to do map m id without having to do map m id? Like, is this just a function? Okay, so that's, and then indices is norm one, I guess, indices. And then we want to return write schema. The question is, are we really normalizing the primitives? Yeah, we are normalizing the primitives, but we're not normalizing the indices. No, we have to normalize the indices because you could imagine this was like, well, not maybe, it would have to be something else. But maybe this is like maybe nat, in which case we'd need to normalize that. Okay. So we need to normalize all three. For undefined value norm. Ah, fuck, yeah, because then I need to turn it back into an array. And that has to be done individually for each one. Well, not really. We can No, we can do that here. Alright. Okay, so this is like array bounds. I think it's bounds. Bounds. This is bounds params. Like that. And this is array bounds indices. Prims array bounds. Text tagged. I don't think I tagged them. No, they're most certainly not tagged. I think you have to tag them here, because otherwise you lose. I guess since these are a bunch of items, the items have the tags, have the source information in, whoops. The items have the source information in them. So yeah, I guess we need to do it here. Damn, that means we can't get away with just using normalize here, because we need to tag it as well. So yeah, okay, we have to do tagged, which I think is a record. It is source and term. Item.source and then term equals that. Now the problem is this one. This should be norm pair. Yeah, you have to pull it out to tag it. I don't think there's any way to avoid that. Okay. We have norm1. This is just normalize the item. But here we don't need that. We just need the tagging. Okay, so we can get rid of this, we can get rid of this. This can be norm with norm pair. Yeah. And this can be norm. Oh, I only need to, okay, I only need to type norm with in front of it. I didn't need to delete that. And so now these should all be tagged correctly. Is that all I need? Yeah, text tagged and tagged. Okay. $65. Do I also need to do this? That's probably not the problem because it was a type error, not a layout error. Oh, this should be second? Yeah, second. feel like I could probably do this with an arrow somehow, but I'm not really up to the figuring out how. Cannot satisfy a constraint. Why do you need that? It's time for a cheeky move. What is this function? I guess it's like A to STS result B and P dot item, and the result is an ST result array word A, something like that. You know what? This needs to be list array like this. Yeah. Is this even right? We have a function which takes, no, it actually specifically has to take an item. No, not true. Not true at all. Yeah, this looks right. Then it takes a P item. And it takes an array of A's. And produces a result list of B's. That looks right. So it's complaining that function type is not in the ST monad. 36. That's an interesting complaint. Yeah, this is the one I want. Yeah, this one in particular is the one I want. Some guy to some monad guy. Some guy to some monad guy. And then some traversable guy. Some traversable guy. Some monad of the traversable guy. Right, because then we then map in on the traversable. Yeah, no, that looks correct. At least this part looks correct to me. Cannot satisfy constraint function type ST. Wait, does it think this guy is the ST? It shouldn't. Cannot satisfy the constraint. Function guy ST. This is function guy. Right? This is function guy. Yeah, that is function guy. There ain't no doubt about it. This is function guy. You'll say this is the worst part of micro Haskell. Its error messages are fucking terrible. Because, and I quote, Error messages are boring. Guess that's how it is. What happens if I run it again? You know, ah, damn, it's the same thing. It's worth a try. So it either thinks this is a function or it thinks this is an ST, and it thinks it should be a function or it should be an ST. Well, I have claimed that it is a function. It should be a function. I'm not sure which one it thinks it is. It almost certainly doesn't think it should be an ST. That seems wrong. It almost certainly thinks it should be a function type. But it thinks that it is an ST type. Why? Is it because one of these things are inferring the type of norm with? Yeah, I think this is fair. Whoops. I think, like me sitting here wondering why I can't just like turn one type into another type easily. Like this is all just like converting from one type to another. Well, sort of. I mean, we are normalizing something in amongst it, but most of this is just converting from one type to another. Which is something that Rich Hickey talks about when he's ragging on statically typed languages, because he's a closure guy, right? He invented it. So he's big on dynamic languages. And one thing that he rags on a lot is that a lot of particularly Haskell code is just converting from one type to another, not doing any meaningful work. And I think that's fair, particularly when I'm sitting here looking at this line of code going, what the fuck, just convert my types. But on the flip side, if this worked the first time, which it doesn't, but if it worked the first time, it would have just been like, oh, I sit down and I spend, you know, maybe 20 seconds thinking about the problem, and then I write the solution and I just move on. I guess the reality is that it is frequently not that way. You frequently end up sitting there looking at it going, why doesn't it work? It's probably inferring... It can't be inferring the type of norm with because I'm declaring it. What happens if I do this? But I think that's a sort of fair observation. They look ugly. Yeah. I guess that's a matter of taste. Column 43. I don't know what languages I like the look of. We've got an L colon emote. We're truly blessed today. Yeah, it should just be doing that, but what is its then? It should be concluding from params. Ah, fuck. Ah, I forgot that it does this. This is a problem with microcabal. Not microcabal, microhaskell. Cannot satisfy that. Yeah, I didn't think so. Oh wait, hang on. What the fuck is this? Schema params, array word, line 75. I think we may be out of the woods with this one. No, we're not. Tagged is not... Okay. Thanks, Clonk. You're the real MVP. Yeah, he gifted me a sub once or maybe twice. I can't remember. He's a good dude. I have given him in return $0 in money. Sorry, Clonk. Can we shout out? Is that a thing? He does that all the time, right? Can we shout out L:Q? Does that work? We call this, I think he gets a notification, right? We call this guy attention seeking. That's what we call this one. All right, no worries, Penguin Operator. I may or may not still be going, but see you later if you're back in time. Was it not? It looks like him. Or is this someone else? Do I need the at? Whatever. You know, you do what you can. Cannot satisfy constraint tagged being an array of shit. This is line 7750. This guy. So it wants it to be this guy. Right, because we've got list array. Where is list array? Oh, we need the bounds. We've got bounds, right? Yeah, we've got bounds. So this, it wants this guy to be this guy, but it thinks it's tagged. Why does it think it's tagged? Shouldn't be. Should be an array. I wonder if it's inferring the type of A from one of these guys and then having a problem applying it. Because I know this is a problem with micro Haskell, is that it will infer these types. And so you need to have a different function if you're going to have a different, you know, a different one of these guys. I hope that is not what is occurring, because it is quite annoying. Oh, this one doesn't have a source, why not? Whatever. So this is text item, this is text item, and this is just item. And the claim is we should be having text tagged array. So this should be text tagged. This is interesting that it can't infer that it's... It can't infer what this is. I'm kind of surprised with that. Spending a lot of time on this function. The hell that is monads. And when it comes to reusing these guys, I can never tell if it's micro Haskell not compiling it correctly or if it is me doing it wrong. What does it think is tagged though? It's certainly not... It thinks this is tagged. Which part of this guy implies that it is tagged? Wait, is it actually a result? That is actually a problem for a different reason though. I am being dumb for different reasons right now. What's the right way to do this? Probably just like this. I think this is probably the right way to do it. And then here we want params just like this. Yeah, just like this. So these should be arrays. Why does it think tagged though? That is so bizarre. I wish I could get a bit of insight into what micro Haskell is doing. "75 cannot satisfy constraint either st." Is that right? I wonder if it doesn't know what monad I'm trying to use. No, it looks like it does. It thinks this is an st. It shouldn't be. After we do this, it should be an either. And then this whole thing should be in either. Cannot satisfy constraint either st. I agree that they're not the same. You have a very keen eye, compiler-san. 75 column 23. Norm width should produce an st. Do we get a different error if we do this? Tag does not match text tag. So this is what I expected, unfortunately. This, I think, is because of the problem with micro Haskell. It's inferred what this function type is, and it's chosen, it's probably chosen text tagged when it should be remaining generic. It should still be generic, but it's inferred that text tag is what, I guess, B should be. I wonder, it would be kind of lame if so. I wonder if the solution here, you know what, let's do this and do this, and we'll get rid of the norm width, and what we'll do is we'll do it manually. Map n over lms of this return dot map m id. We'll see if that makes any difference. Cannot satisfy constraint monad. Really? Where are we? Line 70? Just go away. Yeah, okay. So we solved the problem. We solved the problem by, instead of trying to make this function generic, we wrote it out every single time, which is very annoying. This is a limitation of micro Haskell. Whatever, we'll live with it because we don't, I mean, we guess, I guess we do have a choice, but we don't really have a choice, so we'll live with it. And then we'll call that one solved and moved on with our lives rather. So what is it complaining about? Line 3, 13. How do I count? I think I count this as 1, right? And I should be normalizing this. Oh, I can't. That's a great point. I actually can't normalize the thing I'm currently... Ooh. I think the right way to do this is just ignore the final one. So for the primitives... Yeah, for the primitives you want to ignore everything except the final one. So the primitives actually do need to be different. This is ugly. I'm gonna have 3 of them. What's that called? It's like the opposite of tail. Haskell tail. Yeah, I kind of want the opposite of this. Init? Yeah, init. This function is partial. Consider using unsnock. I'll just use this one. Oh, I actually can't, right? Because it may be empty. It actually can't be empty. Is there any way you can have no primitives in a type? No, because then you can never instantiate it. Wait, is that a problem? I guess that's not a problem. Wait, but if you write a schema, do I allow schemas with no primitives? That's an interesting question. The only other way to do this would be to instantiate, or sorry, to alias the bottom type. I think I'm going for... No, that's not correct. It's not the case that of having no primitives. It's the case of having a function type with yeah, that doesn't make sense. To have a function type that doesn't have any elements. A function type should have... No, that's not correct either. Yeah, so here we either have an atom. Yeah, an atom or a function type. So for the function type, it's the case that we don't... Right, because I guess we also need to check, we need to do the induction check, right? That's part of type checking schemas, is you need to make sure... no, you don't need to type check it for naturals, you need to do it for vectors. But part of it is that you need to make sure that every time... I would have to look up the exact rules, but essentially you need to make sure that you can actually make the type. Is it the type that's the problem? Or is it just when you're pattern matching on it that's the problem? I'd have to look up the exact rules for that. Okay. So when normalizing, we're allowed to have one guy who is unknown, and that is the current thing. That's a complication. I guess we need a new hash map where we insert that guy. But the problem... Can we have... If we make a new hash map that we're going to throw away, the thing we want to avoid is... When we're normalizing using the new hash map, we want to make sure that we never end up defining, or declaring for that matter, new terms. Because when we throw that hash map away, we'll lose them. And I think that's trivially true. I think we're not allowed Schemas and claims can only appear at the top level. They're not allowed to appear anywhere else. How will we have local variables? How is that going to work? Because we could have a special construct, or I mean, we could frankly just have lambdas and then have a macro that expands out into the lambda form. That's probably easier. So you just have lambdas, you don't have to worry about locals. And then as long as we're good at eliminating lambdas when we're compiling, then, which I think is not an intractable problem. I think that is fairly doable, lambda elimination. So as long as we're decent at eliminating lambdas, we can just use them as a way to define local variables without having to declare things. I guess the main problem is our lambda needs a type as well. How are we going to declare the type of the lambda? Do we have an example here? We do. But here, this comes from that. Or is this typeless? That's a great question. It might make sense to have it be typeless, but we need to know we do need to know the types, because when we actually use them, we want to check if they're accurate. I guess this is a form of type inference then, where these guys become the types of these guys. Yeah, what do we want to do about that? What is the right way to handle this? Or even, not even necessarily the right way, but what is the way I want to do this? It would be kind of lame to have to redeclare the types of these variables. Is that what I'm leaning towards though? Because we can hide that with a macro. If we have a macro that does this claim and alias are the same, like just define function, or even just define, frankly. But define function, we can just have the macro spit out all this garbage. So it doesn't really matter if the language itself requires a lot of verbosity, because we can just hide that behind a macro. And does this help us solve our original problem? How did we get here? Local variables, because claims, yeah, right. Welcome back. That was a quick one, Penguin Operator. Good to see you again. Thinking about how I'm going to deal with the problem of when normalizing this, we're going to try to normalize this term nat. And we're not going to know what the definition of nat is because we're currently in the process of defining it. So when we try to normalize this, it's going to fail. So what we could do is create a local hash map just for normalizing this schema that has a definition for nat. And then throw that hash map away. The only problem is if you have a local hash map, if there's another claim or another alias inside the local part, you lose that definition when you throw away the hash map. And I'm wondering what I'm going to do for local variables. One thing you can do is just have a bunch of lambdas. But currently our lambdas don't have type definitions for their parameters. And I'm wondering if that is the way to go or not. It would be annoying to have to re-specify all this crap just in here. But it would make it certainly simpler. So where are we actually doing this? This is primitives, yeah. Oh yeah, indices. Is there something right? So in primitives, when normalizing primitives, we want to know the name of the current thing, but we don't even know that here, because right here we're normalizing a schema. We don't even know the name of the current thing right now. I guess we could put it in the hash map. Certainly the type is in there, but the value is not, and the value is what we need when we're normalizing. So if we go back down here to type checking, during alias, here, just above this guy, we'd have to make a new guy, a new st ref. I mean, I guess it doesn't have to be a new one, we could reuse it, but we could make a new st ref that has an extra definition in it. I think maybe we'll do this for now and think about how we handle lambdas, because that will be our next big problem. So what are we actually going to do? I guess, right, I guess we could add a new one in here that's like self, or not self, but yeah, maybe self. Is that the only thing you have to worry about? In schemas, that's the only thing you have to worry about, that you can reference yourself. And in a schema, you can't make another claim or alias that's not legal. Do I enforce that? I don't think I enforce that. Currently, claims and aliases are only legal at the top level, so I guess I do enforce it. I'm not sure how to handle this lambda situation though. It feels like these guys should be typed and not just by this guy. That would be more consistent with everything else I've done, I think. And what do I turn from normalization? I return a term. And I guess what I should do... Right, this will be when checking equal. So I guess what I want is I want to return a term from normalizing, and then I want to get the type of that term and check if the type of that term is equal to the one I expected. So I guess check equal might be like has type maybe. And then we have a term and a type. That might be the way to go. Then what's the type of a schema? Yeah, I guess actually the type of the schema is not too bad. You need to... It's a function from your param types and your indice types to type 0. Yeah, function from your param types and your indice types to type 0. Yeah, so that's actually not too bad. Yeah, so getting the type of a scheme is not too hard. That's fine. I think I have to have a separate one for primitives. The question is, do I want to put the local definition in the entire hash map or not? Like, what happens if you reference over here? What happens if you reference nats in here or in here? I think that should fail. Yeah, and it should fail because then you would have a function from nat to, like, it would make sense when defining nat to have it be a function from nat. Because it's not currently defined. Though we would catch that when type checking, so maybe we can allow it and then do the type checking. Actually, we might not catch that in type check. No, we would catch that in type checking. So maybe we'll just allow it because it makes the code a bit more uniform, a bit simpler. Or at least a bit more uniform. It makes it a bit more uniform to not worry about this local, to not worry about this local case. Because otherwise we would have to have another one here, which is like locals, something like that. And locals we just sort of throw away at the end. And locals wouldn't be used, they'd be used in schema. They might be used in, I also think I'm coming down on the side of lambdas have to redeclare their types. I think I'm going to get rid of these bindings and have them not do anything and have the lambda declare the bindings. Is there any... no, you should have these bindings because you need them for vector en. Never mind. So we'll keep the bindings. But I think I'm going to have lambdas have to declare their types as well. So it's not just in the claim. Unfortunate, but I think that's the most consistent way to do it. And again, we can hide all that stuff behind a macro, so it's not the end of the world if the primitive form has all this extra information. We'll just emit it through a macro so that the programmer doesn't have to deal with it. Okay. I think I'm landing down on this way of doing it, so we'll get rid of that and we'll have to have a different norm function here for each one. So norm params, norm indices, and this will be norm prims. This will be norm params. This will be norm indices, and then we'll have a norm prims, which for now will be the same, but we'll need to change. And when norming prims, we want, it might make sense to put this in a do block because we'll be doing a couple of things. But when norming prims, we want to add a new guy. No we don't. No we don't actually, because as I was just saying, we'll have the caller do that. We'll have the caller add the new guy. So do we need to do anything else in norm prims? I don't think so. Actually, let's undo this. I don't think we need that. I think that's fine. And then one of the terms needs to be like self. Raffle? No, let me think about this. I don't think so. I don't think it's a good idea to call it raffle. I think. Because refl is usually an equality type between two things. I don't think we should call it refl. We should just call it self. It's fine for it to have no parameters. That's absolutely fine. If self appears... Should we make this text-based? That's an interesting question, because we need some way of knowing what it refers to. If we don't have a name, what ends up happening? If we don't have a name, then... We'll not have a name for now. It's fine. We can add it later. We'll just have a to-do here. To-do. Do we need to also track the name ID of the enclosing type? Okay, so normalize can stay the same. And then what we have to do when defining the alias is we have to go... temp is new stref, read stref str, and then new stref, like that. So it's a new guy. And then here we'll do it with temp. And then we'll throw away temp. No, not quite. Modify stref. Well, we don't have to do it this way. We could modify it first. New stref. Yeah, that's a good question. Because we want to... If it fails, that's a problem. Why would it fail? I guess it would fail for the duplicate evaluation reason, which we'll pick up on later. Is it the only way it can fail? Is there a put that isn't get or put? It's just like put the fucking thing. Did I write one of those guys? I did write one of those guys. Yeah, I want that. So put, or I guess like it's not flip. There's too many guys, right? Yeah, there's too many guys here. So we can't write the we can't write flip. I guess we'll have to do put name tagged I guess item.source. But what's the term? Self. Yeah, it's self. Okay. So now we should be looking up with the temp guy. So that should not fail when we encounter it. Yeah, true. That should be Her Majesty's, or is it his? No, it's His Majesty's at the moment, I think. Yeah, His Majesty's put. His Majesty's puts. What are we shorting? What are we putting? State. Ah, yeah, true. I guess this is like that. Yeah, it's terms. That's kind of lame. Alright, more do notation. This program is just nothing but do notation. So we want this to be read stref str, and then we want to go give me the puts, and you can put this guy. Yep, those are some wonderful puts. Let terms equals we can do it like this. No, you have to do it like this. Whatever, just this once I will indent it. Is that enough indentation? I think so. I think as long as it's indented from the... Well, we need to do that, but as long as it's indented from there, I think it works. Okay, and then we go new stref state terms. Or actually, I think we can just do this like that. I think that's enough. Okay, that is enough, but it's complaining about unimplemented normalize. Line 3, 13. Right, yeah, I haven't normalized self. That's very true, so... Oh, no, that's not true at all, what the fuck? Right, because we haven't done it for p.atom. The only way to normalize an atom is whatever has already been normalized, otherwise it's a failure. So we need to go get or put, nope, get, and this needs to be a case. And we need to go, oh, we haven't even read from the fucking thing yet. So can we go read stref str? And then what is the key that we're matching on? We're matching on name. I really have a way of programming. I impress myself. There we go. And this can be a return, and the values are nothing, in which case it's an error here at item.source, and the error is unrecognized use of undefined like this. Okay, and then under just I feel like there's a function that does this, that turns a maybe into an either with the default value. Okay, what don't you like? Cannot satisfy constraint tagged term. Unimplemented check equals. That is actually correct. That is the problem. We need to check that this schema has the right type. And this shouldn't be check equals, because I decided it should be has type. And so what we're going to do we need 2 tags? Is that... We only really need this to be a term. We really don't need it to be a tag. Is there any reason to tag it? What is def? It comes from normalizing the definition. Is that a tag? Surely... Yeah, we don't need that to be a tag. There's no reason for that to be a tag. In fact, I'm gonna get rid of this. I'm gonna say has type term def, and this will be put end tag, or yeah, put in tag def. Motherfucker. And these don't need to be tags. Is that the problem? Yep, that is the problem. Cool. These don't need to be tags at all. It's enough for them to be terms. Oh no, but error reporting. Never mind. I changed my mind. Yep. Okay. So this is term, or this is value, and this is type. Okay, let's get rid of this, and we need to switch on equal type get type. So equal type Is this the right way to do this? I think yes. I think it's just easy to do it this way. So we'll get the type of value, and then we'll check if they're equal. Then just this, else left, or else error here, val.source. Value has type. Why did I flip equals type? It's completely symmetric. Value has type plus plus pretty print v type, but expected type of okay. Yes, I'm well aware. Get type. This should be term. This should be term. And there's this should just be equal, not equal type. There's no distinction between terms and types, so we're just going to check if they're equal. This is term. No, yes, this is term to term. Yeah, get type equals case. Okay. So what are the cases? We have all these terms. We don't need to do this. Fuck, is it Sunday already? Yeah, it is. Damn. Prim. Fun. Level. Self. Yeah, the type of self, that's an interesting one. It might just be self. No, it can't be. It can't be self. Yeah, I think I do need to track the name so I can look it up. But that requires looking it up. To do this is almost surely wrong. The type of level is level plus 1. The type of a primitive is a function type of that primitive, maybe? I think I can just carry that across. Yeah, I can just carry that across. The type of a primitive is a function of that primitive. The type of a function is... What is the type of a function type? I guess it's level, max level fun. Something like that. And then the type of a schema is a function type. Not exactly. It's not exactly a function type because it depends if there are parameters and if there are indices. Because if there aren't, then it's just a level. Otherwise, it's a function to a level. To do... Actually do this. Okay, so we'll get the type. I guess I don't really need the case here. It's just slightly easier to write, why not? Doesn't cost me anything. And then we want to check if they're equal. I guess we can just implement equality. Why do they have names? Yes, for substituting into the primitives. Oh, that's a good point. I should be defining these locally when doing this guy. I'll have to make a note of that. Probably here to do define the params locally in a for this one. That'll do. Okay, and then so we want instance equal term where what's the best way of doing this? Probably just like this. Do arrays have equality? Yes. Yeah, I think this is the easiest way to do it. Schema. Okay. And I guess we just AND them all together. I don't think this is a reason to do anything else. Is it AND or is it AND? I think it's AND. And then otherwise false. Extra fields, params. Oh yeah, fuck. We can probably just do this. That's probably a better way of doing it. I shouldn't complain about that. Oh, whoops. It will if I leave the commas in though. 47. Cannot satisfy constraint equal tagged. Alright, I can do that. Instance, you know what? It's probably better just to... No. It's way easier just to implement equal and tagged. Tag dot... but that makes them recursive. I don't think that's a problem. We'll see if it complains. 107 undefined max level. Very correct, because I haven't defined it. This is very similar to schema, and I don't want to do this right now. I'll just make it all self. 115. Cannot satisfy constraint. Has field term. Can you not? Right, because this is that. Almost 7. Cannot satisfy constraint, term, item, column 60. Am I really printing items? Surely I want to print terms. Oh, because items have types as well. Can we just do this? Value. Do I need source as well? I do. No, it needs a name. That's my name for you. I hope you like it. Cannot satisfy constraint tagged item. 119. Why do these both need names? I think something's wrong here. Oh, because they're only temporary states. Right, you're never meant to actually see them. Should I just have a pretty print function for terms? It's probably better. Like, that's probably way better. Has unimplemented PP, but expected unimplemented PP. Oh no. But you thought the problem was here? Ooh, I don't know if that's right. Okay, I think I'll try to fix this up slightly and then we'll might end the stream after that. Okay, so now can we pretty print terms? This should be a lot easier to print now because item is just some terms basically. So this should be how should I pretty print this? I might even do the whole shebang. I might even go like claim plus unpack name plus and plus preprint term type.term or item.type.term plus and then plus alias plus unpack name pp term item.val.term. Might I call it val? Whatever. We'll even do that. Why not? Sure. Yeah, looks good. This shouldn't be named. This should be item.name. Fuck, now it doesn't fit. Fuck, it still doesn't fit. Now we're back. Okay, and so pp term should take in a term and return a string, as in a string. What's the best way of writing this? We could probably do a lambda case. It's probably the easiest. Level equals type. I guess we just want to show the level then. Show level. Something like that. We'll just do it like that. Okay, and then that shouldn't be an equals, that should be one of these guys. And then we have fun, unimplemented function, print pp, like that. Then what else do we have? We have a primitive. This is basically the same as functions, to be honest. What's the right way to print a primitive? Like that. That's definitely the right way of doing it. And a schema. Okay, beautiful. Value has type, okay, so we've clearly got this thing wrong, but value has type 0, but expected type of unimplemented schema pp. All right, so now the big question. It has value of val term. No, it does not. Very wrong. This should be v type. Value has type 1, but expected. Okay, this thing's clearly wrong. Where is it pointing? It's pointing at value source. Where does has type come from? Where is it used? Two, 1. Value as type self, but expected type 0. Yeah, and that's correct because currently we're saying that schemas have type self, which is definitely wrong. It's not true at all. This schema should have type 0. I don't like this. I don't like that it's 2, 1. Where do I want this error to be reported? Value has type something. Maybe I don't want this to be an error here. It's probably an error range. Do we error the value? I guess so. What is the value here? D, which comes from the definition, which comes from normalizing the definition. I don't think 2, 1 is correct. I don't think we're normalizing that correctly. Oh, normalization just gives a term. It doesn't give... Oh, it doesn't have source information. This tags it. What are we tagging it with? Item source. This is the start of the alias. I don't know. Is tagging it with the start of the alias the right thing to do? Because we're really tagging the definition. That's kind of what we want. We should probably be tagging the definition source, not the item source, to be honest. Two 14. 214. Yeah. Yeah. And this has type that, but expected type that. Yeah, that's more correct, I think. Rather than tagging it with the item source, I don't think that's right. I think you want to tag it with the definition source. This is an interesting question. I don't know what source to put here. Probably the schema. That's where self was defined. So we'll probably go def source again. It's probably the right thing to do here if there's ever an error. Yeah, because this is only defined, this self item is only defined when the schema starts. Okay. Let's get rid of all the tabs. Alright. I think that's probably enough for today. I left myself with a bunch of to-dos to get to over the next week. Bunch of shit that needs doing. Yeah, I really got to think about this self thing. I think I probably need to keep track of the name. But then, I don't know. I think I need to keep track of the name so I can look it up and get the type. But then that means all of this needs to be done in the ST monad. It doesn't need to be in the monad, but I need to get the type array, which is probably the right thing to do anyway. Because when looking up primitives, I don't know. I'll have to think about it. But I think that'll be it for today. And I gotta see how much of the stuff I need to do for tomorrow I can get done before I go to sleep. All right, and that'll be all for now.